Hello everyone, my name is Pipin Abram and in today's video we'll talk about integration, which is one of the mathematical tool for doing physics. So in today's video we will talk about what actually is integration, and we will look around some of the formulas which are very useful as far as physics is concerned, right? Because a lot of times we are always get stuck because we do not know the integration of some of the other kind, right? So we get stuck and we just don't know what to do next, right? So today's video, it will be helpful for those students who are very weak at integration and who do not know any basics about integration. So this video will actually help you guys to understand integration better. So let's get started. Okay, let me start with a simple question, that is, can we draw a graph of y is equals to 2x function, right? So basically a simple graph which we study in our lower classes. So the answer is how we can draw the graph. It's pretty simple. We just do the hit and try method, right? We just put values here so that we can get your x and y coordinates. Let's say you have, if you take your x to be 0, your y also comes out to be 0, right? If you take your x to be 1, the y comes out to be 2, right? And if you take your x to be 2, the y comes out to be 4. You take your x to be 3, the y comes out to be 6. You take your x to be 4, the y comes out to be 8. You take your x to be 5, the y comes out to be, yes, 10. And you take your x to be 6 and the y comes out to be 12, right? So you got at least 1, 2, 3, 4, 5, 6, 7 coordinates you got. Let's try to plot these coordinate in this graph. The graph you guys can very clearly see. This is the graph. I have already made the graph here, right? So I'll just simply plot them. The first coordinate is 0 comma 0, right? So let me just very quickly plot 0 comma 0. Yes, 0 comma 0 is this point, right? Okay, great. Next is 1 comma 2, 1 comma 2. This will be that point. I hope you guys can understand that. Third one is yours 2 comma 4. 2 comma 4 is this point. Great. Next point is 3 comma 6. 3 comma 6 is this point. Next one is 4 comma 8. 4 comma 8, this point we are talking. Next one is 5 comma 10. 5 comma 10, this point we are talking. Next one is 6 comma 12. 6 comma 12, this point. So you guys can very clearly see I'll get a straight graph, something like this, right? I'll get a straight graph, something like this. Okay, great. Now I got the graph, right? Now the thing is, what I will do, I actually want to find out the area under the graph. Now how I can find out the area under the graph? I hope you guys can see a triangle, right angle triangle, being here. I hope you guys can see that. So I got a right angle triangle and I want to find out the area under that graph, right? So this is the area under the graph which I would like to find out, right? For this function, that is y is equals to 2x, right? That I can very simply find out because this is basically a triangle. So this distance is actually 12. And let's say these values are in centimeters, right? I forgot to mention that. Let's say these values are in centimeter. So this distance will be 12 centimeter. I hope you guys can understand that. What about this distance? This distance is actually, yes, you have guessed it right. It's actually 6 centimeter, right? So for a triangle, we all know if I want to find out the area of a triangle, the formula is half into base into height, right? So here, half into base into height, right? With this formula I can actually find out the value of the area of the triangle, right? Or area under the graph here, right? Okay, now what is the base over here? Can you guys see base is actually this, that is your 6 centimeter. And what is the height over here? Height is actually 12 centimeter. I hope you guys can understand that, right? So all I have to do is put the value half into base. Now what is the base over here? Base is 6 centimeter multiplied by height is actually 12 centimeter. So area under the graph comes out to be 3 times of 6, 12 3 to 36, 36 centimeter square. Now that was very easy. Why it was very easy? Because the function was a linear function, right? We were getting a linear graph. There was no curves over there. So it was very, very easy to find out the area under the graph, right? Now what will happen What will happen if I have a very curvy kind of a graph, right? For example, if my graph is not linear in nature, how I can find out the area under something like this, right? So you guys can see it has lots and lots of curves. I want to find out the area under this graph. Now how I can find out, right? So in order to solve these kind of problems, it becomes very difficult to solve these problems by a conventional method, right? I can divide it, I can divide it into a rectangle, but still this part still left in order to find out the area, right? So what we do, we simply apply a simple trick over here. What I will do, I will basically take a rectangular strip of a very small length. A very small length is, is actually represented by the symbol dx. So I will take a rectangular strip of very small thickness, and obviously its y dimension is the corresponding y-axis, which is obviously the coordinate of this particular point, right? So a strip of very small thickness and corresponding y as the length, right? So I'll take this strip and imagine I can take lots and lots of these kind of streak over the entire area. Can you guys understand that? I can imagine, or I can visualize lots and lots of strip along the area, right? And if I can find out the area of a single strip, and then I can find out the area of all the individual strip, and I can just add all the areas, will I get the value of the entire area of the figure, the area of the area under the graph? Is that a yes or no? Right? All I have to do is just simply imagine lots and lots of rectangular strips of dx width and corresponding y as the length. Is that a yes or no? So that is the idea over here. So you guys can see, I can assume we can choose a small rectangular strip of dx length. Dx length means very small length, right? So I can just imagine something like that. It's basically a rectangle. Can you guys see here? It's actually a rectangle which has a width of dx and length of y naught. Is that a yes or no? So area of this rectangular strip, somebody asked me what is the area of that small rectangular strip. It's simple, length into breadth, right? So length into breadth, that is y naught times of dx. Simple, right? Now I can visualize, yes, like I was saying, I can visualize that my entire area is actually made up of these small lengths, these rectangular strips of dx width and corresponding y length, right? So if I want to find out the area of this entire figure, all I have to do is add the areas of your individual strips till this particular point, right? Let me just say this is my dA, that is a small area, that is a small area of the strip, dA naught, then this is dA1, and so on till your dAn. I don't know, you can imagine it can be made up of n number of rectangular strips. Is that a yes or no? Right? Okay. Now if you look closely, if I zoom it out, you guys can see here, still some part of the area is still left out. Can you guys see that? Some part of the area is still left out. I'm not getting the actual area under the graph here, right? Some part of the area is still left out. You guys can see there are a lot of loopholes here. Is that a yes or no? Right? Now how I can, take away that loophole? The answer to the question is, what can I do here is, I will make this dx length so small. I can make this dx length so small that my curve will feel like a line, right? So it's pretty simple. Let me just make you guys understand. Let's say I have a curve. Right? So I'll make the dx so small. That it actually coincide with a line. And if it coincide with a line, so you guys can understand, if it coincide with a line, it's basically the line. Can you guys understand? So that there will be no gap here, right? So the idea is that I will make my dx tending to 0. Tending to 0 means it is not 0, but it's approaching 0. It is very small. If my dx is very small, then the strip will match the curve. Can you guys understand that? If my dx, that is the width of the rectangular strip, is very small, right? If my dx, that is the length of, that is the width of your strip, is so small, then these gaps will be filled. I hope you guys can understand, right? Okay, I can make one more example here, right? So this is the, let's say, curve, right? And let me just make the strip very very close to each other. So if the strip is very very close to each other, it will feel like a line. Can you guys understand? It will feel like a line, and that line, for that line, that rectangle, that curve itself will become a line. I hope you guys can understand that. Yes, so it's basically a method. So in this method, you have to be very careful. Your dx must be very 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 small, so small that we should not get these gaps, right? So these gaps you guys are seeing because I have made the dx very large, right? Because I have made the dx large so that you guys can visualize it, right? In other cases, the dx is so small that these curves that you're observing, that will feel like a line. I hope you guys can understand that, right? Okay, so now all we have to do is just find out the area of individual dx's and just add them till all of your strips are completed. Yes or no, right? So it's pretty simple. So you guys can see, let's say for the first strip, the width is anyway same for every strip, but the corresponding y-axis length will be changing. For first strip it will be y0, second strip it is y1, for third strip it will be y2, and so on till your yn strip, right? So the areas, the corresponding areas will be dA0 will be equal to y0 times of dx, dA1 will be equals to y1 times of dx, dA2 will be y2 times of dx, and so on till your dn. I hope you guys can understand that, right? Okay, so the area of the entire figure, will be the area, will be the summation, or I can say will be the addition of all the individual strips, right? So it's pretty simple. So area of the entire figure will be simply dA and summation over your n is equals to 0 to n, that is your entire strips are included, so that is equal to dA0 plus dA1 dA2 till your dAn strips. Is that a yes or no, right? That will be the area under the curve, right? And very important, I have taken the limit dx is tending to 0 because I want to find out the exact length, right? So I will make my dx so small that your curve will feel like a line, right? So that is limit dx tending to 0, summation of n to the n is equal to 0 to n times your dA area, right? And that will be equal to, so whenever I have this limit dx tending to 0 summation sign, I change my sign to sign like this, which I call as the integration sign, right? So whenever you have a summation in which your dx is tending to 0, right, or your strip or the width of your strip, whichever you have chosen, it is actually very very small, at that time instead of summation I use this symbol. This symbol is what you call as your integration symbol, right? And it is integrated towards, you guys can see from 0 to xn, right? From your this strip to your this length strip, it is integrated over this entire strip, right? Okay, so that is integration, your y is your corresponding length multiplied by dx. Dx is the thickness, right? The small thickness that we have chosen, right? So this is what integration is. So what is your integration? Addition of area of small strip to make the complete area of the figure. Addition of area of small strips to make the complete area of the figure. I hope you guys can understand. In other words, what is integration? Let's say it is written y dx. Now what integration is giving you? It is basically giving me the area under y versus x graph, right? So you guys can see this was your graph, y-axis, and this was your x-axis, and the area under your y versus x graph is what is your integration is. Can you guys understand that? Yes. Okay, so y dx means area under y versus x graph. What about x dy? X dy will be simply area under x versus y graph. Pretty simple, right? What is v dt? V dt, area under v versus t graph. I hope you guys can understand, and obviously a lot of things will come. Let's say somebody asks what is integration of z dy, that is area under z versus y graph. I hope you guys can understand that. Yes. Okay, I hope clear hai, right? Okay, now Let's talk about different types of integrals. Now, integrals are of different types. One is your indefinite integrals, other one is your definite integrals. Now, indefinite integrals are always written like this, y dx. Now, whenever we talk about indefinite integrals, they are not definite in value. You cannot predict the definite value. So there are no limits involved in indefinite integrals. So whenever we get the answer, let's say this is my answer, we are always adding a constant because we do not know the exact value of your integral. That's why we call them indefinite integrals. So whenever you have an integration in which your limits are not specified, all those integrals are what you consider them as indefinite integrals, right? And whenever we are doing those integrals, the answer must include a constant because we can never predict the exact value of integral until unless boundary conditions are given to us. I hope that is understandable. On the other hand, there is something known as definite integral. That means you can predict the exact value of those integrals. These integrals will be those integrals in which your limits are provided. That is, your y dx is being integrated over your some definite limit x1 to x2. The limits are given. So for these kind of integration, you are not supposed to add any kind of constant because they themselves are definite in nature. The integration, the answer, the integral answer will be the definite value because you have confined them under some limits. I hope you guys can understand, right? Okay, great. Now let's come to the important point, that is the formulas, which are very important as far as physics is concerned. And let's try to understand the formulas one by one, and let's take some examples too. Okay, so let's talk about the first formula, that is your x to the power n dx. Whenever you have an integration like that, answer will be x to the power n plus 1 upon n plus 1, and obviously you guys can see there are no limits over here, so there will be a constant involved. And remember, this formula is only applicable when the value of n is not equals to 1. So the moment the value of n is equal to minus 1, this formula is not valid. I hope you guys can, you guys have to be very careful about that. Okay, now let's talk about some examples here. If example is x to the power 3 dx, the answer is yes, x to the power n plus 1, right? That is x to the power 3 plus 1 upon 3 plus 1. And that will be x to the power 4 upon 4 plus your constant c. Second example, x to the power 4 dx, the answer will be x to the power 4 plus 1, and that is 4 plus 1, and this is x to the power 5 upon 5 plus constant c. I hope that is understandable. Yes. Okay, let's go to the next rule. Constant terms will always come out of your integration. Yes, whenever you have a constant term which is multiplied with your integration, it will always come out of your integration. That is, example 3x squared dx, if you want to integrate that. So the 3 is the constant term which will come out of your integration. So 3 will come out, and then you simply integrate x to the power 2 dx, that is 3, then that is x to the power 2 plus 1 upon 2 plus 1, and obviously the constant c. I hope that is understandable, right? The answer will be x cube plus c. Now you guys can do this question by yourself. Don't look at the solution. You will get the answer. The answer is 4x to the power cube, x to the power 3 upon 3 plus c. Right? Okay, let's move forward. The third property, how can we solve when the value of n is actually minus 1, that is x to the power minus 1 or 1 upon x dx. So whenever you have this kind of integration, the answer to this integration is log base e x plus constant. This is the integral value, and this is the constant term we are adding. You can write your log e base x as your natural log because both have the same meaning, ln x plus c. So whenever you have an integration of 1 upon x, the answer is log x base e or natural log x plus c, right? For example, if you have an example 1 upon 3x, so 1 upon 3 is the constant which will come out of your integration. You're left with 1 upon x, that will be 1 upon log base e x plus c is your answer. Is that a yes or no? I hope clear. Okay, let's move. Next one, integration of e to the power x dx. Whenever you have an exponential function like that, the answer will be the exponential function itself plus the constant sign, right? Okay, let's talk about some trigonometric function. Integration of sine dx, you will get answer to be minus cos x plus c, right? So minus cos x is the integration, plus c is the constant value, because we are talking about indefinite integrations, right? Cos x dx, integration of cos x dx. So basically integration of cos x dx is plus sin x plus c. Integration of tan x dx, the tan x dx integration is natural log sec x plus c, right? So these are some integration which you have to by heart, right? Remember them because they will be useful. Integration of cos x dx, the answer is natural log cos x minus cot x plus c. Integration of sec x dx, answer is natural log sec x plus tan x plus c. Integration of cot x dx, answer is natural log sin x plus c. Integration of sec square x dx, answer is tan x plus c. Integration of cos x square dx, answer is minus cot x plus c. So these are some integrations which you have to remember, right? Because they are just remember, and just wherever these integration come in physics, just apply the direct formula and then just do it, right? Okay, great. Now there is one important property which is there is this important method to solve integrations. Whenever we get a complicated integration, we can solve it by using integrating by parts. For example, we always use ILATE rule. Now ILATE rule means your I stands for inverse trigonometric functions, that is your sine inverse x, the functions which are like inverse in nature, right? L stands for your logarithms function, that is log base e x. A stands for your algebraic functions like 3x square plus 2. Your T stands for your trigonometric function, that is tan x, sin x, cos x. And E stands for your exponential function. Now I have written ILATE. Now what is the meaning of ILATE? You have, whenever you're integrating by parts, you will always have two functions. For example, let's say you are integrating x e to the power x. Now your x is a different function, e to the power x is a different function. Your x is actually algebraic function, algebraic function, right? And your e to the power x is actually exponential function, right? So these two functions are different, and when you're integrating them with a dx over here, right? So you have to use integrating by parts, because there is no other way you can integrate them. So it's basically a rule, and how you can do it, it's pretty simple. The rule is you have to choose your first function and your second function, and this ILATE is the rule of choosing your first function. So if you have two functions, one function is your inverse trigonometric function, and the function is your log function, then you have to choose your first function as your inverse trigonometric function and choose your second function as your log function, right? For example, in this particular example, I have algebraic function and exponential function. So you guys can see algebraic function comes here and exponential function comes here. So obviously algebraic function is higher in rank, so you have to choose algebraic function as your first function and exponential function as your second function, and then solve it, right? Because this is very important. If you're not choosing your first and second function very carefully, you will mess up the integral, right? So this is very important that you choose your first and second function very carefully whenever we are doing integration by parts, right? Okay, so the first priority is always given to inverse trigonometric function. The second priority is log function, third priority is algebraic, then trigonometric, then exponential, right? So if you have two functions, like for example, if you get an inverse trigonometric function and algebraic function, the first priority will always given to inverse trigonometric function, right? First rank, second rank, third rank, fourth rank, and fifth rank, right? So whichever function you are stuck with, whose rank will be higher will be chosen as the first function, right? So for example, if you have chosen your first and second function, then you have to solve it like that. So let's say fx is your first function, gx is your second function. So you have to take fx outside, then integrate gx dx, right? Integrate your gx, then with a minus sign, differentiate your first function multiplied by your second function, then whole integration of the function. Let me just show you with an example, then only you will be understand it properly, right? So let's talk about this same function, that is x e to the power x. Now algebraic function and exponential function, we all know you will take your algebraic function as your first function and exponential function is as your second function, right? So first function will always come out, that is your x will come out, then you will integrate your second function. So I am integrating my second function ex dx. then with a minus sign, integrate it, differentiate your first function. So this I have differentiating my first function multiplied by your second function multiplied by my second function, then the whole integration of the entire thing, right? So when I differentiate my first function over here, the answer comes out to be 1, right? Because dx upon dx will be 1. When you integrate your second function, e to the power x dx integration is e to the power x, right? So this is x e to the power x minus, here you have to integrate 1 multiplied by e to the power x. Again the answer will be e to the power x, and obviously do not forget the constant sign, because this is an indefinite integration. The answer is x e to the power x minus ex plus c. I hope that is understandable, right? Okay, let's move with one and very important topic, that is definite integral. Now how you can do definite integration? Let's talk about this example. So you have to integrate x square plus 2x plus 3 with your limits, that is 1 to 2. You have to integrate it from 1 to 2. So how you will do it? You will first of all, you'll distribute the integration. So first integrate it 1 to 2 x square dx, right? So first one you distributing it, then the second one integrated 1 to 2 2x dx, yes or no, and then again distribute it to the third one, that is 3 dx 1 to 2, right? So after distribution you have to solve the integrations. So x square, that is x to the power n, right? So this function, so the answer to this one is x to the power n plus 1 upon n plus 1, yes or no? So the x to the power n plus 1, that is x to the power 2 plus 1, that is x to the power 3 upon 3, and then apply the limits like that, 1 to 2, apply the limits like that, plus your 2 is a constant which will come out of your integration. So 2 came out, then solve it. So this is again x to the power 1, right? So this is x to the power 1 plus 1 upon 1 plus 1, yes or no? That is x to the power 2 upon 2, yes or no, which is written over here. I hope you guys can understand. Then apply the limits from 1 to 2. Very similarly, 3 is a constant quantity which will come out of your integration, right? And here it is written x to the power 0. So I can write x to the power 0 plus 1 upon 0 plus 1. The answer is x to the power 1. Is that a yes or no? Right? So 3 will come out, you will get x only, and this is integration 1 to 2 as your limits. Is that a yes or no? Now how you can apply the limit? Now this is very important. How we can apply the limits? This is very important. Now limits are always applied upper limit minus lower limit. Upper limit minus lower limit, right? This is how you actually use the limits. So the answer is x to the power 3 upon 3, right? So you apply the upper limit first, that is your 2. So that is 2 to the power 3 upon 3. Wherever the x is, you apply the limit, right? Minus, this is your lower limit. Apply 1 as your lower limit, that is 1 to the power 2 upon 3. Very similarly, in this one also, upper limit, apply the upper limit first, that is 2 to the power 2 upon 2, then minus the lower limit, that is 1 to the power 2 upon 2. Very similarly, upper limit 2 minus lower limit, I hope you guys can answer, 2 minus 1. Is that a yes or no? It's pretty simple, right? This will become 4 upon 3, this will become 1 upon 3, and this is 4 upon 2, this is 1 upon 2 and 3, this is 2 minus 1 as 1, right? So when you solve it, the answer comes out to be 7. Is that a yes or no? So I hope you understood most of it, because these are the basic formulas or basic techniques that we will do in order to do our basic integration, and in order to solve most of our physics part of your integration. Is that a yes or no? I hope that's understandable. If you have any doubt, you can comment it down in the comment section. That's all for today. Thank you and have a nice day.